Hello, guys. Good evening. Welcome to the session. And let us start. Today's session is, of course, about cloud computing. And this is for people, it's like a beginner guide. People for who are looking to switch their careers into the cloud computing, or if you are a completely fresher, you are seeking job opportunities in cloud computing, or if you're already working in an IT sector, your client, you got a project from the client where you need to fetch a knowledge related to popular clouds in the market, any one of the popular cloud, or might be the trio, mostly GCP, Azure, AWS. So for if you are in this, whether you are seeking to know about the cloud computing, or if you're a fresher, or if you want to switch your career, so this is like a beginner's guide where we are going to discuss what is cloud computing, and what are the clouds, that are there available. There are a lot of clouds, and we will majorly talk about the three enterprise level clouds, which are leaders in the market, that is AWS, GCP, and Azure, and we will make comparison between them. We will start our session by understanding what is cloud computing, and then we will go and look into the opportunities, why actually cloud computing, need of the cloud computing, and also we will talk about our course content. And also, let me check with you guys about my audio quality. Just I'll post a poll. Okay, I have published poll for you guys. Just confirm by choosing yes or no. Is my audio clear? Excellent. 100% yes. Okay. We will get back to our presentation. Yeah, cloud computing, right? And I'll briefly introduce myself. My name is Shrija, Cloud Solution Architect, and I have been delivering trainings for past 4 years. And I have worked mainly on AWS, as well as these days I'm working on Google Cloud Platform also. So let us start understanding what is cloud computing. Okay. These were our topics we are going to talk in today's class. Cloud computing and advantages, of course, cloud deployment models, service models, and then we will make a comparison between on-premises versus AWS or any cloud, and comparison between the cloud providers and course curriculum. Okay, let us start. So, to talk about cloud, first we should understand what cloud is. So, might be many of you know what cloud is, but if you are a beginner, if you wonder what is a big deal about the cloud, let us look into its definition. What is cloud service and what is cloud computing? Cloud computing provides a simple way to access servers, storage, databases, and broad set of application services. And cloud computing is on-demand delivery of compute power, database, storage, applications, and other IT resources through a cloud service platform via the internet with pay-as-you-go pricing. That's what there on my screen. In simpler terms, if you ask me to define a cloud computing, I would say that is IT and infra services provided for us as a utility. like how we pay electricity bills, we use electricity and we pay bill. We use water and we pay water bill. And we use a lot of other amenities and services and we pay bills. So all these are utilities we are using. We actually don't bother about how they are maintained, how they are. Suppose if you say electricity, we are consuming electricity, but we actually don't worry how it is getting generated and how power grid works, how it comes to our household. We only bother about using it and paying bills. And cloud computing is also the same concept. IT resources, IT and infra resources provided for us like a utility, and we use them based on our need of our applications, and then we pay on a pay as you go pricing on a monthly basis. Sometimes you can opt for yearly pricing also, mostly it will be monthly pricing. So that is cloud computing. Let us understand how this cloud computing started. Applications, right? Applications, web applications, right? These days everything has become online. If you want to order groceries, order clothes, or if you want to book an appointment with a doctor, or if you want to send an email, if you want to do some work related to your office, whatnot, everything has been online. That means you're able to access everything through online. But actually people don't maintain computers, they won't spend time in hiring people and creating applications, especially non-IT sectors. If you take hospitals or hospitality industry, banking sectors, so all these digital online, simply we can say one of the contributing factor behind the digital transformation is cloud computing. So let us understand what any application needs. Any application, it can be e-commerce site where you can shop clothes, etc., or it can be your office web application, or it might be a project, client's project which you are working upon. It might be your banking website. Anything, any application needs resources, and these resources are provided by the server. Actually application resides on server, so that server provides compute power, storage, networking, databases and analytics. Of course not only server, and other infrastructure provides all these things. Previously, before the advent of cloud computing, everything used to be on premises, right? Let's go back. Sorry. Everything used to be on premises. People used to maintain these servers, and people used to build applications which are going to be run on those servers, and these applications used to consume those storage, compute power, database services, etc., from those servers. And now we are moving to cloud. Cloud is nothing but someone's data center. Instead of we maintaining all these things on premises, I can just use it and pay, use whatever I want, and I can also use up to what point of time I want those services, and whatever consumption I have made to that duration, like our electricity bills, we pay bills. Simply say, for example, if I want to launch a grocery online application, just give me a minute, guys. Yes, guys, I'm back. And I got a message on chat saying Kiam no ang, say no audio. Is that, guys? Is that with others also? Is any uh, are you able to hear me, guys? Just respond over through chat if you're able to hear me. Okay, it's okay now. Great. Thank you. Let's get back. Yeah, yes, it no audio. Yeah, yeah. I think now you people will be able to hear me. Let's get back to the presentation. So what we are discussing is any application. Let us consider if I want to launch a grocery application where people can come and buy products online, book and buy products online. I need to build an application, and for that application, I need a server, and I need a server. Server is nothing but a computer. That means it has to provide compute power and storage, and then I need a database for to store all the information coming, like suppose the number of people getting registered into my web application and other details, and all those entries to be made in databases. And for if I want to save my product related details or any other details, I need any other storage apart from database, like images. If I want to store any image, audio, video, I need any other storage capacity. And of course, I am launching my application on the internet, and I need a scalability and flexibility options according to the traffic coming in. I should be able to scale up the resources or scale down the resources so that I can optimize the cost. So these are considerations when any business, small, large, or medium, if they want to come into online, or if just an organization, if they want to go for cloud. So these are the considerations, right? If this has to be done on premises, if I am launching a grocery store and if there is no cloud, I have to buy servers, and I have to lease or rent or buy a space for these servers, and I have to configure the network, I have to configure the storage, and then I have to install various microservices like databases, server applications, and other microservices which are required to build the application, and everything should be maintained. All these are cons, disadvantages if cloud is not there. So to resolve this, in 2010, before that also clouds were there, but enterprise level clouds, that was the first entry made by AWS as a cloud providers. AWS declared itself as a cloud provider, and in 2012, a well matured AWS providing enterprise grade services came into the market. And if you want to launch any application, web application, or if you want any resource or a service through internet, AWS is providing basically compute, storage, database services initially, and later on there is something called as platform as a service, software as a service. These are also they also came into the picture. And cloud is nothing but someone's data center. So instead of you maintaining your data center is nothing but the servers which you set up is putting together. We call it as a data center. So um, cloud is nothing but someone's data center. You virtually use the resources of cloud and pay the bill. That's what we have discussed. Computing as utility we are getting. And cloud just it's not providing, it's not just someone's data center, it's beyond more than that. We will talk about it. And on my screen you can see on-premises considerations and AWS or any other cloud, public cloud advantages. So the first advantage, if you move on to the cloud rather than maintaining your servers on premises, is of course cost. There won't be capital expenditure. You need not worry about buying the infrastructure. And then about the space, the one-time investment which you have to spend, you need not worry about it. You just go and opt for whatever services you need for your application, and you pay only for the consumption. And that's not the case if you set up the things on premises in your data center. So there won't be a capital expenditure. And coming to operational expenditure, which are recurring prices like salaries, bills, and HVAC costs, and licenses, other things which are recurring, maybe every month, some are on term basis. So those things will also be there. Cloud is all about it goes on pay as you go pricing. You have to pay bill every month. But comparatively with the on premises maintenance, that is also less, very very less. So there is no capital expenditure, and operational expenditure can be greatly reduced if organizations opt for cloud. And the second thing is easily manageable. You need not worry about setting up and maintaining the infrastructure. Not only infrastructure, operating system, security, firewalls, network, and lot more other things. You need not worry about maintaining them. So cloud manages those things for you. You only bother about your application and the data. Right? And great scalability and flexibility is provided by the cloud. Suppose you know that or you not even guess that traffic is going to increase in the next minute or in the next hour, but in the next hour for your web application the traffic has doubled or tripled, or even it has got 10 times than the regular traffic. If your application is running on a single server like this on premises, right, so your server, what happens is it will become out of order. That means server will hang up. And that's not the case if your server is on the cloud. If your application is running on the cloud server, or if your application is running on any of the clouds provided or cloud managed services, that's not going to happen. You can easily scale it up because cloud is already having resources in abundant, and they are providing it for you on a monthly basis as an utility. If you want more services, you can opt for more services, and also you can automate it, the process of scaling up and down. And great scalability, flexibility, or elasticity is provided. And when you don't feel like you having those, you don't want that services, you can delete them and they won't be billed. right? So why cloud computing? You can save costs and comparatively more security than on premises. Why? Because these giants like AWS, Azure, GCP, and there are others, but these trio is considered as giants in cloud provider market. There is IBM, there is Oracle, there is Cisco, Alibaba, and a lot more. So the security they maintain, comparatively, the firewall or the security or the encryption they maintain is comparatively good and up to date when rather than you maintaining it on premises. And 24/7 availability, flexibility, capacity, just now we have discussed, and less deployment time, mobility, quality control, etc. You can see on my screen. So now we have discussed what cloud computing is. So let me go back once. Cloud computing provides services that are on demand. When I say services, services related to compute power, services related to storage, networking, database, analytics, and lot more. So these days we have game development, we have OTT platforms, we have other things. We have machine learning, and we have analytics, advanced analytics, AI. So cloud also provides all these services, and there is a platform for all these services. It's not only the things on my screen. These enterprise level clouds provides platforms for all of the technologies or platforms that are on demand in the market. So then only the cloud can be called as enterprise level cloud. And now we know what cloud is and why, what is the need for cloud computing. And if you see on my screen, traditional and virtual architecture. Traditional is nothing but on-prem data center, and virtual architecture. In the virtual architecture, which cloud has adapted, using this virtualization layer, the same hardware, underlying hardware, can be used by multiple applications. Whereas in the traditional architecture, whatever application is running on the server, that's it. So you set up your server, and the application will run on the server. And whereas cloud, using the virtualization layer, will share underlying infrastructure with the applications, a variety of applications. Okay, and also let me check the chat box once. I'm not able to see when I share my presentation. Let me check once. Okay, let me go back. That was brief introduction to cloud. And now if you see on my screen, these are enterprise units in 2021, and this type of services they are adopting on the cloud. They are storing files, office software, email, security software, and app development, testing, and financial accounting software. There are lots, CRM, hosting enterprise database. If you see all these things are happening on the cloud. That means organizations are no longer preferring to keep the software or to keep their application and maintain it on premises on their own servers. Why? Because just now we talked about advantages and disadvantages. That means there is demand for the people who are able to manage these services, who are able to work upon these services or maintain these services. And that's why this cloud is also providing various certification to validate the knowledge of the people who are able to work upon the cloud. So we will also talk about it. Before that, we will talk a bit more about clouds. First, we will start about NIST model of cloud computing. NIST stands for National Institute of Standards and Technologies. As the name suggests, they set standards. Suppose if I have a set of, I have some space, if I set few servers on it, and I have got my virtualization. I have done my virtualization. I can share this set of servers to any others through that virtualization. So that is a concept similar to cloud, right? Can I call myself as a cloud provider? Maybe, but not a enterprise level cloud provider. According to NIST model, these were the essential characteristics a cloud should have. Broad network access. First of all, any cloud vendor, if they want to be a cloud vendor, there should be broad network access. That means globally available, not in one place. They should have their infrastructure across the globe. Broad network access, rapid elasticity. So if I want storage, I should be able to create. If I want to delete, I should be able to delete. Rapid elasticity should be there, and of course scalability also. If I want to go for more number of servers, or if I can automate according to the traffic to have more number of servers. Rapid elasticity. And cloud is not, if someone offers just a compute power, some storage, so it's not technically it's cloud, but it's not considered as a cloud provider, a proper cloud provider in the market, because a proper enterprise grade cloud provider should make on demand services available. So whatever services are on demand, say for example in mobile development or web development, or in any application development, or in analytics, and lot more. So on demand services should be available. And resource pooling. Yes, say I have my cloud account, my friend also has a cloud account, let's say AWS. I have created account in AWS, and my friend also have account in AWS. I have launched a virtual machine, and I'm doing some projects on my virtual machine. And when I'm leaving my AWS portal, I just shut down my virtual machines. And when I shut down my virtual machine, the same infrastructure is assigned to my friend, right? Who is also who has also created an virtual machine. That means resource pooling is happening. When I'm not using a resource, it's shared with someone else, but accounts are logically separated, and what you are working upon the resource, that is logically separated, but the underlying hardware, the CPU, RAM, ROM, storage, etc., those were shared between the users. That's why these type of clouds are called as public clouds, which work on basis of resource pooling. Otherwise, the clouds are called private clouds. And if a cloud works on both, provides set public as well as private, it's called as hybrid cloud. And there is community types of clouds. Community clouds means these clouds are not enterprise level clouds like AWS, Azure, GCP. Salesforce is an example of community cloud, and there are few clouds related to IoT. They provide services. They have broad network access, rapid elasticity, measured service. That means cost should be shared with us upfront. Even before we launch the service, we should be able to calculate the costs. So measured services. But some clouds may not provide all the on-demand services. Services related to all the domains. So certain clouds will provide services related to certain domains like CRM. So a particular cloud is providing only CRM kind of services which are required for CRM. Certain clouds only provide for a service to collect data, save data, and generate some alerts, etc. But you cannot build a gaming application on particular clouds. So those were community clouds. Okay, and as of now, any doubts, guys? Clear the concept of cloud computing? Okay, let me go back. And we need to talk about these service models, which are important. Now we understood about the cloud and what cloud provides, and what are the essential characteristics of the cloud, and different types of cloud like public, private, hybrid, and community. But what do cloud contain? Cloud contain many things, and many things related to, as we have seen, whatever are required by your application, whatever that are on demand in the market, cloud provides those things. Especially the cloud which we are talking, um, enterprise grade clouds, they provide on demand self services. And again, these on demand self services can be categorized into three types. Those were SaaS, software as a service, IaaS, infrastructure as a service, and PaaS, platform as a service. So some of you might have already, might be familiar with these terms, but let us brush it up again. So whatever things that are on demand, cloud provides them, and you can make use of it, build your applications, and pay on monthly basis. And again, like how we have different plans. If you take your telecom operator provides you a different plans, in the same way, the same compute power or same storage or a same database is available in two different variety. We'll talk about the first one, infrastructure as a service. Infrastructure as a service means you will virtually get infrastructure. Instead of having infrastructure on premises, you will be able to get it virtually, and you pay just for the infrastructure. And when you don't want that infrastructure, whatever infrastructure you have provisioned on your cloud portal, if you delete it, you stop paying for that infrastructure. That means if you launch a virtual machine, what you are getting is infrastructure as a service. You are getting a computer. You are not buying a computer. It is not physically present on your premises, but you are virtually accessing a machine computer from cloud's data center. So that is infrastructure as a service. Virtual machines, containers like Kubernetes, Docker, Terraform, which also runs on virtual machines, again, are infrastructure as a service. And if I want to launch my infrastructure as a database server, I can install MySQL server on the virtual machine, and I can maintain my database. I am responsible for managing the operating system, database, security. If any other microservices are installed in that virtual machine, security of those applications, and all these were my responsibilities. And these kind of services are called infrastructure as a service. You only get infrastructure. Of course, cloud secures the hardware, cloud maintains the operating system to the basic level, not firewalls, etc. And also the virtual layer which brings you the virtual machine, which allows you to access the virtual machine. That's it. So after all, rest of the things should be managed by you. That is infrastructure as a service. And PaaS, platform as a service. So just now I took an example of making your virtual machine as a database server. You install database and manage the database. Rather than that, cloud manages database for you. You need not worry about launching an virtual machine, and then you need not worry about the platform, that is operating system of that virtual machine, and then installing database and managing it. Just give me a minute, guys. Very sorry about it. Okay, let's go back. Okay, infrastructure as a service and platform as a service. Platform as a service, if you take a database, you can launch it on your own virtual machine. Then the kind of service you're getting from the cloud is infrastructure as a service. Same database is available as platform as a service. You need not worry about launching a virtual machine, its operating system, its security, and the storage of your virtual machine, and then the database installation, managing security of your um, database, etc. So cloud manages all those things for you. You only handle your data on the database. So what you're getting is platform, which is readily available, already configured. You just go provision it, and you need not worry about maintaining. That is the platform as a service. Database you are getting as platform as a service. Okay, sorry about that. I'll just go here again. Okay, and there is SaaS, software as a service, and most of the cloud providers which we are discussing are public cloud providers, majorly AWS, GCP, Azure. Most of the services will be infrastructure as a service kind or platform as a service kind. SaaS might be one or two services will be like SaaS, but most of the services like are IaaS and PaaS, platform as a service. SaaS, SaaS, whatever application you are using with the help of internet and the browser is SaaS, software as a service. No dependencies, nothing to be installed on your side. Nothing has to be configured, provisioned, or managed from your side, like Google Drive, like Facebook, like Uber, whatever you are making use without doing anything, like managing it or maintaining it, or SaaS applications, software as a service, Microsoft Outlook, your OneDrive, all these are SaaS applications. Most of the SaaS applications we are using are free. Some SaaS applications like Microsoft Outlook or Active Directories, they are provided for organizations on license basis. Those were SaaS applications, software as a service applications. And these are different services, I mean different kind of service models on the cloud. And not only AWS, the other clouds also provide these both of these, infrastructure as service and platform as a service. And now we will go back again. At the starting of the class, we discussed about the cloud, and we discussed about what cloud provides, and now we discussed about the service models, platform as a service and infrastructure as a service. Cloud provides a lot of things, and cloud certifications is all about learning how to manage these services. It can be infrastructure as a service or platform as a service. Design your architecture using these services. So the kind of role, if you're a guy on an organization, if your organization is developing applications on the cloud, or if your organization itself is there on the cloud, or the projects are happening on the cloud, and if you are architecturing them using this infrastructure as a service and platform as a service kind of services, you are a cloud architect or a cloud engineer. Suppose you are creating the applications, you are developing the applications, so then you'll be called as a cloud developer. Or if you are a system administrator but on the cloud, now you are a system admin for the infrastructure as service and PaaS service provided by the cloud, then you are cloud system administrator or cloud DevOps engineer or a cloud developer. If you are a data scientist, but if you are handling data on the cloud, if you are building your machine learning algorithms on the cloud, then you are a data scientist with, then what eligibility you should have if you want to approach to some organization and call yourself a guy who can work upon data analytics on the cloud, then you should get those certifications. So we will also look into those certifications. Yeah, here. AWS certifications. As I told, if you are architecturing the projects based on the services that are available on the cloud, you are called as solutions architect, cloud solutions architect. And there is associate level, professional level, and you have to AWS conducts these exams. Not only AWS, other clouds also conducts these certification exams. If you clear the exam, you'll get a certificate. That means you are eligible to architect the systems on the cloud. And there is associate level, professional level. And if you see here, there for operations, sysops administrator. For developers, AWS developer certification is there, and at professional level, DevOps engineer is there. And this is the basic level. Suppose if you are a project, a team manager or a quality manager, or if you are someone who are not actually into the technical team, but still, if you are a business, small scale business owner, and if your business is running on the cloud, say AWS, even though you don't work upon your application, you should need some knowledge. So the basic foundational knowledge, cloud practitioner is the certification, which you can study and clear. And these were specialty certifications for advanced networking, dealing with big data, security, Alexa skill builder, machine learning. All these are specialty certificates. Similarly, same certifications is available on other cloud also. We are mainly talking about these three clouds: AWS, Azure, GCP. If you see similar kind of certifications for fundamentals and for administrators, that is for system administrators, developers, AI engineers, for data scientists, data engineers, and again for solution architects. So this is in Azure and this is in GCP. All right. So rather than studying these different types of clouds, what one should understand is architecturing, understanding the cloud itself. So these clouds more or less will be similar. There will be similarities. At the end of the day, what cloud is? Cloud which provides on-demand services. Cloud is providing on-demand services, the same compute, the same virtual machines, storage, database, etc. And the terms might be different, but the set of services provided by these clouds are same, more or less. There might be some differences, but more or less, if you understand analogy of one cloud, and with some bit of effort, you can also easily understand the other clouds. So that's a brief understanding about the cloud, and we have also seen different types of clouds and different types of service models. And as I said, this is a beginner's guide for people. If you want to switch your career, or if you're a fresher, or if you are a person who is in IT but not yet worked upon the cloud, and if you got a project, and now if you want to fetch a knowledge regarding the cloud, this is the session to help you guys. We have talked about these different types of clouds, and let us also understand. Let me just go. We'll make some comparisons between these clouds. I think it's here. AWS, Microsoft Azure, and GCP. There were other clouds like Alibaba, IBM, Oracle. These clouds, yeah, they are also used by enterprises, but only when the enterprise which you are, or organizations which you are working in, and there is a need that organization want to have a database in Oracle cloud, say for example, or in an IBM cloud. If you organization has tied up with an IBM cloud, and if you want to launch your projects in IBM cloud, then you can go for it. But in the market, most of the job descriptions looks for AWS, Microsoft Azure, Google Cloud Platform, either solution architects or developers or DevOps engineers. So these three clouds were Janes, and you can also check in the same in this Gartner's Magic Quadrant. These three were the leaders in the market, and AWS is on the top, and the second place, Microsoft is in the second place, and Google is in third place. And also, this is due to their age also. AWS is made its entry in 2012. Microsoft, Google, comparatively, or recently launched services. And these three are high in demand in the market, and the people, either solution architects or DevOps engineers or data scientists who can work upon these clouds, are high in demand. Let us make a brief comparison between these clouds. Suppose if you want to switch your career, as I said, or if you want to start learning on a learning cloud, where should you start? This depends. So if you want to switch a career, or if you want to, if you are a fresher, if you are someone who is already in IT, or if in a non-technical sector, it's better to go for all these three clouds, and especially the clouds GCP and Azure, because just now I told you AWS has huge demand and also huge competition. And a lot of organizations are preferring people who can work on AWS. At the same time, organizations are also considering Microsoft Azure, GCP. These clouds are also providing very, very promising services. Suppose an organization which works on .NET projects or SQL servers, obviously will go for Microsoft Azure. And data scientists, data analysts, If you have if you're able to work on GCP is providing a great services for those things, and AWS is all rounder, and also it's a old entrant in the market. So it's better to have knowledge about all these clouds if you're a fresher, or if you are looking for a career switch, or uh, for those guys, that's what I recommend. Suppose if you're already working, maybe you are a manager or a team lead, and now you got a project on a certain cloud, and then based upon your project and where you need to work upon, then you can opt for the cloud. And one more suggestion I would make here is, these clouds, if you are new to these clouds, it's better to start it from solution architect or a foundational level, where you will understand about all the services, and then can move on to other technical kind of certifications which we looked here. DevOps. Suppose if you're a developer, you can directly go to developer certification. Okay, let's go back and look into this comparisons. AWS, high demand. A lot of demand is there, and you can also see AWS is leading position in the market. And according to the demand, supply is also there. Whereas Azure, GCP, Azure is great if you're a .NET developer, or if your organization is having SQL servers. You can go for Microsoft Azure, or if your organization is having Windows servers, if they want to migrate them, then Microsoft Azure, you'll get a good salary package, and wide range of cloud certification paths are there. And GCP, significant growth rate is in the market. GCP is the late entrant. It came in the recent times. It is customer friendly, and also high paying job opportunities because lack of people, as it is uh, recently arrived. So let us also look into the job opportunities once. I have looked into different job portals in India. We have Naukri and different forums, and came up with these statistics. Let me share it with you guys. So this package might vary according to your roles and responsibilities. And I am a cloud solutions architect. And so these were the statistics related to cloud solution architect. Annual package salary range for a cloud solution architect, you can see over here. And coming to jobs in USA, for AWS, there are around 40K jobs. I'm talking about cloud solution architect role. And Azure 19K jobs, and GCP 8K jobs. There is 8,000 jobs. So there is a lot of potential in the market, and future is going to be on the cloud, because everything is becoming online. Everything is becoming online means everything is moving to the cloud, and cloud is improving day by day. It enhancing with respect to of its cloud managed services like PaaS services, and also optimizing the costs. So cloud in near future will become a must have knowledge. So for anyone who is looking forward to work with data, or forward to work with developing something, or creating something like IoT product, uh, for everything, cloud has become a central point for data scientists, or for developers, or for solutions architects, or for system administrators. And coming to our course agenda, before going through that, let me ask you guys, I'll post a poll. Okay, just now I have published a poll. Let me know. Yes, 100%. Great. Okay. Let us also look into our agenda. As I said, we 360 Digit MG, we provide trainings into emerging technologies. And coming to the cloud computing, we have solution architect associate level certification in AWS, in Microsoft Azure, and GCP, Google Cloud Platform. And you have an option of opting for all the three with the name of comprehensive cloud computing. The same solution architect, which is called as a cloud engineer in GCP, and solution architect in Microsoft Azure. So you can also opt for all the three certifications in, I mean, the same certification, but in three different clouds. And also, we offer certification for DevOps engineer in AWS. DevOps in AWS and solution architect certification in AWS, GCP, and Microsoft Azure. So let us understand what solution architect. Just now I have also discussed solution architect is a guy who architecture the solution. So before going to the solution, first let us, there should be a problem. If I am calling myself as a solution architect, I am providing a solution, architecturing solution for certain business problem. Business problem can be anything. It can be launching an application, or it can be maintaining services on the cloud, addressing the non-functional requirements for the existing application, like costs, making the application highly available and resilient, taking backups, maintaining the costs, launching the applications, maintaining the applications within the budget, and also architecturing the solution. If it is a new project came, say for example, a banking website has to, they want to come online, a bank, a particular bank. So what services they have to use on the cloud, and how they are interconnected. Simply creating an architecture blueprint, not only creating the blueprint, and also addressing the non-functional requirements, as I said, maintaining the cost, maintaining the availability, resiliency, and then all these things are also roles and responsibilities of a solution architect. And the solution architect, there are different kinds again. Solution architect who architecture and who will be like an mediator between the technical department and the client. And some solution architects also involves into technicalities like database system administration. But anyways, so the course content which we cover is enough to clear solution architect certification in all of these clouds: AWS, Microsoft Azure, and GCP. And also we have AWS DevOps certification available, the course content related to it. And coming to examination, after undergoing the course contains all, most of the things will be hands-on. That is one more beauty with the cloud. Nothing is, I mean, very little theory, and almost everything is hands-on. Great way to learn. And the second thing, coming to cloud solution architect level certification, is very less technicalities are involved. If you are not a great developer, if you are not good at programming, uh, you need not worry. As I said, cloud solution architect is a person who will be the front face, who will be more, I mean, dealing with the client side. If you are a developer or a DevOps engineer, then yeah, you should be having sound programming skills, system administrating skills, operating system managing skills, etc. Okay, and coming to our agenda, so we will talk about different types of clouds. I'm talking about comprehensive cloud computing. If you want to opt for only solution architect in AWS or only solution architect in GCP, yeah, you can also do that. We will be talking about deploying servers, load balancers in all the computing platforms, that is AWS, Azure, and GCP, storage services, and security services like identity access management, securing your applications, and then networking, how to configure the network, how to isolate the services by networking, databases in all the clouds, and again AWS, Azure, and GCP, content delivery, and then domain setup, how to deliver the content globally. If your application is running from, say, I'm located in India, if I have in my organization, servers are located, of course, in the cloud. We don't know where they are, but we know the region. We have an option of selecting the region. Suppose within the AWS or within the GCP, my server, if it is running on in Mumbai, and I'm getting global traffic, and how to deliver the content from these particular region. Domain setups, setting up the domain name, DNS servers, publishing notifications, queuing, monitoring services. Machine learning services is an add-on thing which is actually not required, but we provide this machine learning service in all of these cloud as a value add. So that's the overall agenda, guys. Okay, if you have any doubts, you can please type in chat window. So just now we have seen this, right? If you enroll for course in 360 mg, you can attend a multiple session for 1 year. It's not, your enrollment is not for single batch. Lifetime access to LMS, learning management system, with recorded videos, which you can access those recorded videos, and training material will be available in the LMS, and you will have lifetime access. So we will be having quizzes in that LMS. Assignments will be there for each module. So internship is in the space of analytics, and also in cloud computing, we provide something called as capstone project. Internship as such is not available in cloud computing because it's not possible to have a live project in the cloud. So there is some capstone project for cloud, and we help you in resume preparation, mock interviews, job placement assistance, and support for your other projects. Okay, thank you, guys. And also, don't if you want to follow us, yeah, these were our social media platforms, and especially our YouTube channel. We will be posting our webinars. We will be posting the latest content. See, if you take cloud computing itself, cloud is enhances day by day. Cloud improvises the services, and it launches the new services. Suppose if you already have your knowledge on cloud computing, or if you have already done the certification, but if you want to know about the new services that were launched, etc., so please visit our YouTube channel. We will be posting webinars on such a kind of content, and also please visit the other social media platforms too. Yep. And that's it, guys. Hope you have enjoyed the session. Okay. And yeah, if you have any doubts, you can please post in chat box. Okay, then. Take care, everyone. Yeah, please visit 360digitmg.com and also our social media channels. And bye bye.